find this video helpful, please like, subscribe and press the bell icon for notifications. Today we will be looking into our fifth and sixth property of determinant. So fifth property is, if some or all elements of any row or column is in the form of sum of two or more terms, then determinant can be expressed as a sum of two or more determinants. So if any row or any column has more than one term, say suppose it has 3, then it can be expressed as a sum of 3 determinants. So let's understand this with this example, and let's take a determinant A is equal A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3 as the first row, and then B1, B2, B3, C1, C2, C3, second and third row. So each element of the first row is a sum of 2 terms. Now take A1, A2, A3 as the first row of a determinant, and second and third row will remain the same, that is B1, B2, B3 and C1, C2, C3. Now plus sign, and then take lambda 1, lambda 2, lambda 3 as the first row of the second determinant, and the second and third rows will remain the same, that is B1, B2, B3 and C1, C2, C3. So similarly we can have all the elements of any column as a sum of 2 terms. So here we can take first column as a sum of 2 terms, that is A1 plus lambda 1, B1 plus lambda 2, C1 plus lambda 3. Then second column is A2, B2, C2. Third is A3, B3, C3. Now take the first term of the first column, that is A1, B1, C1, and write it down as the first column of the first determinant, and the second and the third column will remain the same, that is B2, A2, B2, C2, A3, B3, C3. Now plus, now take the second term of the first column and write it down as the first column, and the second and the third column will remain the same. Now the sixth property says that linear combination of any 2 or more rows or column will not change the value of its determinant. So let's understand this by taking a determinant A, that is A1, A2, A3, B1, B2, B3 and C1, C2, C3. Now let's replace row 1 as row 1 plus lambda times row 3. So add row 1 with lambda times row 3, and we will get first row as A1 plus lambda C1, A2 plus lambda C2, A3 plus lambda C3, and the second and the third rows will remain the same, that is B1, B2, B3, C1, C2, C3. So according to the sixth property, value of this determinant should be equal to the value of this determinant. So let's take an example where A is equal to 1, 2, 3, 2, 1, 4, 0, 1, 1. Then its determinant will be 1 times 1, 4, 1, 1 minus 2 times 2, 4, 0, 1 plus 3 times 2, 1, 0, 1, which will give us 1 minus 4 minus 2 times 2 plus 3 times 2, that is minus 3 minus 4 plus 6, that is minus 1. Now let's replace row 1 with row 1 plus 2 times of row 2. So our first row will become 1 plus 2 times first element of row 2, that is 2. Then 2 plus 2 times second element of row 2 is 1. Then 3 plus 2 times third element of row 2 is 4. And the second and the third row will remain the same, that is 2, 1, 4, 0, 1, 1. So after simplification, we will get 5, 4, 11, 2, 1, 4, 0, 1, 1. So now let's take its determinant and expand it along the first row, and we will get 5 times 1, 4, 1, 1 minus 4 times 2, 4, 0, 1 plus 11 times 2, 1, 0, 1, which will give us 5 times 1 minus 4 minus 4 times 2 minus 0 plus 11 times 2 minus 0, that is 5 times minus 3 minus 4 times 2 plus 11 times 2, that is minus 15 minus 8 plus 22, that is minus 23 plus 22, that is minus 1. So both determinants are same. So linear combination of any 2 or more rows or column will not change the value of its determinant. In our next topic, we will be learning about adjoint of a matrix. Thanks for watching.